Hello everyone, I am Bradley Sward, Associate Professor of Computer and Information Science at the College of DuPage in Glen Ellen, Illinois. And this video today it's a little different than most when it comes to these puzzle advent calendars. Usually I write my code and do my stuff in Python, but I figured I would do things a little differently. Here's a visual proof for day 7. You'll see the problem here in a couple seconds. And to provide the visual proof, I used the one software tool since I do gaming sometimes on the side, and I did that in my past life. So I've used using GameMaker Studio to show the visual proof for this. So I'll show you the code behind it, which isn't there's not a lot of code, but it'll show you everything going on. So here is the problem. So it's a regular decagon, 10-sided figure, and regular means all the lengths all the sides have the same lengths and so forth and so on. You have these 8 triangles that they're all triangles that are red, and you're like, if the area of basically every one of these things is the same and every one of these is 240, well, what is the total area of all the red triangles? And you could look online, so you could start this thing and go online and look up all the definitions of if the area is 240, then what is the side length, and then figure out the heights and all the angles and all this and all that, and you will get to the same result. But let me show you a visual proof on how you can get yourself to the answer. So here's what I did. This is not by any means a description of how to use GameMaker Studio. Those of you who do know GameMaker Studio, then you're in for a little bonus treat. And this is not perfect by any means. I just hacked this thing together, because once you hack it together, the answer becomes pretty clear, and you don't need it to be absolutely perfect to kind of get a feel for it. So I have a sprite, and I imported, coming back to our image here, I imported this thing, and I created basically one for, a sprite for every image here, for every regular decagon. So if I go into this sprite, you can see all 10 shapes, or maybe you can see all 10 shapes, 8 shapes, sorry. 1, 2, 3, 4, 5, 6, 7, 8. Those are the 8 images. And I did my best, I centered it, and again, the picture that was on there wasn't perfect, and again, if I was doing this for real, I would definitely do this a little more nicely. But again, biggest deal. So those are my 8 pieces, and so what I can do here is set up an object using that sprite. And the hardest part for this was just getting to figure out how to start this thing without having to hard code it. How to get this thing to show a different image for different one of the image for the eight different pieces. So I say when I create this object, I say, okay, I have to do this image speed equals 0, otherwise your mind melts from the animation speeding up, and everything just flips through at 60 frames per second, animating through those 8 frames, which is not what I want to do. I want it stuck on something. And then this is one of those things I never use globals, but I used it today because it's a quick hack. And I'm using this so that I can maintain which image to show. And actually, I probably don't need the alarm. I do need the alarm if I'm going to do this. And I say I set my alarm to 1 game frame just so that I don't have a race condition, or everything gets lined up the same. And when this alarm hits, I use that global image value, which is 0, and they say, oh, I get numbers. Like as these objects are getting created and the alarms are being hit, I go, oh, I get image index 0, and then it increases, and then the next object goes, hey, I get 1, and that increases, and so everybody will get. All of the 8 objects in my scene will get a unique number for which animation frame to show, because I want to show each of the 8 different frames, just like in the example. And the only thing left to do then is that when I press the object with the left with the left mouse button, I just increase the angle by 36 degrees, and that 36 degrees is just look it up. That is what a regular decagon is when it comes to the number of 10 sides, 36 degrees. I can rotate this thing 36 degrees at a time. And when I run this program, what do I get? Let me make sure I do it over here on this side. And again, I did not make this anything where I could drag it or anything, but you can get a feel for this. And I go, okay, let's see. If I move this thing around to this, you can see then that this little guy gets trapped up in here, right? Because it's from here, this position down to, and everything in between there. So this little guy can go in here and fill that space. I don't have anything where I can do that. And then what I can do now here is rotate this guy 1 over, and now you see from this guy to this guy and then to here, That part of the image is now filled in. So that part of the, and then this is already filled in from here. And then this guy fills in the rest of it. And so this fills in this part, right? And then this fills in this part, and this fills in the little part. And what do you know? That happens to be half of our image, half of the decagon. And if I just continue on now on the other way here and just do it, the hardest part is just kind of getting it filled in properly here. I did not test out here. Let's see. So I got that going for me. I got this going for me, and I got that going. Nope. Uh-oh. Okay. But it's the same idea. There we go. I think I got it now. I think I did it. There, I think I did it now. So if this is one half of this, this goes into this guy just the same. And then this guy goes into here just the same. And then this fills in the remainder. And so all 8 of these things together are going to total the area of the entire decagon. And so as much as, that one was an easy, if you were going to guess one number without knowing anything, you would probably get, I would say you'd guess 240, because that is the answer. Because every one of these 8 put together give me the whole area. So this guy goes into there, this goes around there. Yep. And that is what I believe the answer is, using a visual proof, using GameMaker Studio. So if this is incorrect, please let me know, and I will promptly erase this video and let my tail go between my legs and go, oh my goodness, what did I do totally wrong? But I think I got this one working for us here. So please comment below and let me know. And so visual proofs can be just as valid as any other types of proofs, like in this example. It kind of shows everything off, and I don't need to go mathematical, and I don't need to spend hours figuring out all these little details of every point in there and figure out the size of every triangle using all sorts of crazy methodologies, since none of those are right angles, or very few are right angles. And so there we go there. So thanks for sticking it out with me as always. Have a great day, everybody. Hope to see you in future videos. I hope to make future videos. I hope these problems don't get too hard in this and the advent of code this year. The advent of code last night kept me up for longer than it should have. And anyway, thanks everybody. Have a great day. Talk to you later. Bye.